Welcome learners. The course that we are studying is Programming for Problem Solving C. Today we are going to start with the second unit of the syllabus, that is Constructs of C. The topic for today is Introduction to C Programming Language. But before we begin, let us do a recap of what all was covered in the first unit. So you understood what a computer is, what are the different parts of a computer, what are input devices, what are output devices, storage units, what is primary storage, what is secondary storage, what is a central processing unit. Then you understood what an operating system is, how it actually is the backbone of an entire system, what are the utilities or what are the functionalities that an OS performs. You understood assemblers, compilers, and interpreters, and the differences between the three. Then, flowcharts. Now, a flowchart is basically a pictorial representation of developing logic for solving any given problem. Pictorial representation is very intuitive to a human brain. So, looking at a page of statements versus a diagram, obviously a diagram is more appealing. And that is why flowcharts are widely used because they are intuitive in nature and they are easily understood, right? Algorithms, on the other hand, are English-like statements, right? So, algorithm would follow a step-by-step sequence that needs to be, executed or that needs to be followed in order to reach a particular result. It is finite in nature, so it always ends. A pseudocode, on the other hand, is somewhere in between an algorithm and a programming language. See, you might know one programming language or you might know multiple programming language, but a pseudocode is independent of any language. So it is a beautiful transition from algorithms to your programming language. Hence, pseudocodes play an important role, right? Because you understand what are the various types of instructions that you can write in any programming language, and the syntax may change for a language, but a pseudocode gives you knowledge of what that construct is, when to use what, when you are making a decision, when you are repeating certain statements, and so on. The objectives for today's class are: what is C, what are the features of C, uses of C language, what is the basic structure of a C program, and then we will look at a small program, a greeting program which would print a hello world message onto your console or your output graphics for today. So what is C? So C was developed by Dennis M. Ritchie in 1972 at the Bell Telephone Laboratories. So Dennis Ritchie is actually known as the founder of C language. But the official publication of C programming language was done in 1978 by Kernighan and Ritchie. And this language actually revolutionized the computing world. From that day till today, and it is 2020, you all are still learning C. So that is the impact that this language left on the computing world. It is the backbone for any language. It is a backbone for so many softwares that you might be using, right? So it was developed to overcome the problems of the previous languages that were B and BCPL, right? So now, obviously, it is an advanced version, and hence, it dealt with the shortcomings of these previous languages. Initially, C was not developed with an intent of, becoming a popular language. It was actually created, it was actually developed to be used in your Unix operating system. So, in 1983, the American National Standard Institute established a committee to provide a modern, comprehensive definition of C. So even more powerful features were added in subsequent years, right? And this ANSI, ANSI C was completed in 1988. What are the features of C, right? It is simple. C is a simple language in the sense that it provides a structured approach to break the problem into subparts and rich set of library functions. Now, the previous languages did not explore this idea of breaking your program into subparts and solving and working on those subparts and then integrating them together, right? But C thought of that. So you could divide your complex logic into simpler small chunks. You can work on those chunks and then you can get your work done easily. Along with this, you have a rich library. Now, what is a library? In normal sense, a library is where you have lots of collections of books and magazines and research articles, right? And you can use them whenever you need them. You just need to go to a library, sit there or issue a book, and you return it when the utility is done, right? Similarly, we have libraries here. And these libraries have some predefined functionalities which we can directly use. So you don't need to create everything from scratch, right? You already have some basic, actually not basic, you have a wide set of functions that are already there in these libraries. So hence, this makes your language very simple to use because of availability of so many functions and data types. It is a mid-level programming language in the sense that although C is intended to do low-level programming because it is used to develop system applications such as kernel for Unix, hardware drivers, etc., it also has features of a high-level language. And that is why it is known as a mid-level language. So it has, it also interacts beautifully with your hardware, but it also supports feature of a high-level language. That is why it is called as a mid-level language. It is fast and efficient. C programming language as a middle-level language provides programmers direct access to direct manipulation with the computer hardware, but higher-level languages do not allow this. Now, as you know, C is a middle-level language. It is intended to do low-level programming, so it beautifully interacts with your hardware, right? And hence whatever instructions that you write are directly being used by the hardware with very little manipulation, right? So or conversion. But when you talk about higher level language, what happens is in between your hardware and your language there are multiple layers and your code transforms from one level to another to maybe some more levels until it can actually be understood by the hardware. So this conversion from one thing to another and then to another, leading to finally the instructions for your hardware, takes time, right? So that is why these higher level programming languages like you can say C++, Java and all, Python, all these take more time, whereas C programming language is fast and efficient. Portability. Now portability means you can carry a thing from one place to another. But here C language enjoys this portability in terms of that programs which are written in C language can run and compile on any system with either no changes or very small changes. And so whatever program that you're creating on one system, there is a higher chance that it will run on another system, right? So it is not just now system dependent language like assembly, right? It is portable. So you can use the same code on multiple languages and hence that is a very beautiful feature. It has a rich library. Like I said, that there are lots and lots of inbuilt functions. Now all these functions do not exist in just one library. You have multiple header files or library files, and each library file has multiple functionalities related to one particular idea, right? We will be looking at these in subsequent classes, but for now I think this should be enough for you. Just draw similarities between an actual library and a C library. And a actual library has lots of books which you can use, you can issue, you can use them and then read them and return them, right? Similarly here, you have a rich library of functionalities. You don't need to write everything from scratch, right? You have functionalities to do a lot of things. So you can use those functionalities with the help of these libraries and you can get your work done easily and more efficiently, and it saves you time and effort, right? Along with this, you have the beautiful concept of memory management. Now, it supports the feature of dynamic memory allocation. But what is this? See, instead of fixing that every program would get maybe 20 kilobytes of memory and there are 5 programs running, you have a beautiful concept of on demand. You can borrow memory. So if I want to use a particular amount of memory at the runtime when I'm executing my program, at that time I can borrow this memory from a pool, free pool memory. I can use this memory to store whatever data that I want to store. And when my work is done, I can release this memory so that any other program can use it as per their need. So that is dynamic memory allocation. The memory is allocated to you when the program is actually running or executing, right? It is easy to extend. Now, extend means that, see, there are lots of functionalities, there are lots of inbuilt functions, but that does not mean that that is the end to functionalities. You can create your own functions. Programs written in C language can be extended, which means when a program is already written in it, then some more features and operations can be added into it. So it does not mean that I have written one program and now that remains fixed. I can add some more functionalities, I can edit it, I can add some more lines of code, and I can add some more functionalities as per my need. So a program can be extended. It is not like create once and then it cannot be modified. You can modify it to add more and more features, right? So that is why it is easy to extend any program that you have written in C. What are the uses of C? Now, some examples of the uses of C might be operating system. This one you all know because that was the reason why C language was created in the first place. Unix, Linux, all these are written in C. You have language compilers. Obviously, compiler for C is also written in C, but other languages also like PHP, right? You have assemblers, you have text editors, you have prince spoolers, network drivers. So a lot of hardware related, instructions are written in C language only. Then you have database, connecting your program to database. So you have drivers for that, and those are all might also be language interpreters, utilities. So the beauty of C is that it is being used almost everywhere. Maybe you know it, maybe you do not know it. Maybe it is being used in some small component of a big application, but it is still being used. And that is why it is important for you to know this language because this is the backbone of all the languages that have come forth and that are gaining popularity today, right? Over the years, I think this is the most elegant language which has been trending over these years, which is still being used and which will still continue being used in the future as well. So now moving on to the next topic, which is a structure of a C program. Now every programming language has a specific way of writing a program, right? That is the structure of that program. So C follows a basic structure which includes some components. Some are mandatory, some are optional. Like the first one is preprocessor directive. Now what is pre? Pre means before something, before processing, right? So preprocessor directives is basically you are going to include your rich libraries here. And what is the utility of those libraries? Maybe you want to use some function that is available in that library. Now, until and unless you go to a library and you issue a book, you won't be able to read it, right? Or you at least have to find that book in order to read it, even if you're sitting in that library. So that is the idea here. If I want to use some already created function, I need to tell where it is lying and I need to tell where is its definition, how is it going to work. So for that we have these preprocessor directives. Here we are going to include those rich libraries so that we can use the functionalities that are available in those preprocessor directives. A preprocessor is a stage before the actual compilation or conversion of your code to a machine code, right? You all know what a compilation process is. So preprocessing happens before the compilation. What happens in this stage is if you're including some library. So what will happen is all the functions that are present there will be made a part of your program. so that when the code is compiling, it knows, hey, this method is going to be found in this particular library. So you can identify what it is supposed to do from the definition that is available in those libraries. Okay, so that is why it is called a pre-processing stage. So these are pre-processor directives. Then the second part is actually optional. Global declarations. Declaration means any declaration mean identifying that this particular thing is existing. Now, if I want to declare an integer variable, I want an integer value. So maybe you all know the concept of integers, right? So I have an integer x and I want to put a value 20 into that x integer, right? So what I'll do is I will make it global if I want that this x can be used by my entire program. So global declaration means whatever is being written here will be used or can be used by your entire program. Whereas local declaration means it can only be used inside the sub block that it is being declared into. All these things will become more clear when we talk about variables and then global and local variables. For now, let us just understand that a global declaration means that whatever you're declaring here in this global scope can be used in entire program following it. Whereas a local declaration means that the whatever variable or a function you're declaring can only be used inside that block or that sub block. Okay. Now, this int main void. Main is the most important component of your program because this is from where your execution starts. Main is a method, it's a functionality. And as you study functions in mathematics, every function is supposed to do a particular task, right? And you might give it some input and it might give you some output. It might return you some values or some data. So similarly here, main is a method, right? Which can be intended to do some particular task. It can take some input parameters. Right now, it is taking void. Void means nothing, empty. So it is not taking any input. And it is returning you int, int, eger values with the help of int. Now int and void are keywords here. We'll be coming to them in the next lecture. But for now, let us understand that main is a method from where the execution starts. This is the execution point of your program. And it takes some input parameters and it might return you some output. Not output exactly, but it might return you some information. So right now my main method is taking no arguments and it is returning integer value inside. So now every function has this curly braces, which means it is the body of that function. And here we'll tell what this function is supposed to do. So we can have some local declarations here. We can have multiple statements here. And then we need to close this function. Following this, we can have other functions also as per our requirement. Say for example, I want to input two values from the user. I want to read or take two values from the user and I'm interested in, say, squaring the two numbers. So I want to calculate the square of both the numbers individually, right? So what I'll do is I will take the inputs from the user in main maybe, and then I will create another function, square function suppose, whose purpose is going to be to square these two numbers, right? So I can have multiple functions in my program. So main is one function that is always going to be there, but apart from that, we can have other functions as well. Now it makes sense to, divide your entire program into these small functionalities so that these functionalities can be reused as other components. Also, we need not unnecessarily make functions, right? Only make functions when they are needed. If I'm interested in calculating the square, I won't make a function for cubing or for calculating the square root, right? Because it is not needed. It is not a part of my problem. So make functions only relevant to the program or the problem statement. Why? Because we don't want our code to be bulky, right? If it is going to be bulky, it is going to take more time to compile and it will grow in size. So we want to create functions only when necessary and as per our requirements. Now a greeting program. So what is the intent here? We are trying to print a hello world message onto the console or the monitor. For that we have written some very basic code. The first line here is hash include, and in this triangular angular brackets, you are seeing this stdio.h. Now, what is this stdio? See, STD stands for standard input output, right? Standard stdio is input output. Now, this is a header file. Okay? Okay. So, hash include. Now, what is this hash include? Hash is a preprocessor directive that I was talking to you about in the previous slide. So, here, a preprocessor directive to include standard input output functions in the program. Standard input output functions means maybe this file has some functionalities that help me take input from the user or from some source and give output. So it is a standard input output library file, and it has some functionalities that maybe I want to use in my program. So that is why I have included this file. Okay. Now, following this, we have this int main void. So main is a method which is not taking any input argument right now, and it is returning you some integer value. Now, we have used this printf method here. Printf is a function. It is an inbuilt function. Inbuilt means that it is already existing in one of the libraries that we have used. And the library that we have used is stdio.h. So this printf function is already available in this standard input output header file, right? And we want to just use it. So I don't need to write a code of my own. All I need to do is I need to include the particular header file which has this method, and then I can freely use this method. So here printf is being used to display a hello world message onto the console. That was the intent. It is a greeting program. I want that this message should be printed on the console. So whatever is in double quotes becomes a part of your console. So I've written hello world exclamation mark here. So what is going to happen is this hello world message is going to be printed onto the output or your console. And /n is basically going to take you to the next line. We'll talk about this in the subsequent lectures. But this is a very simple program where we have written a hello world instruction to be printed onto the console. This is how our code looks like. So these are lines, lines from 1 to and so on. Okay, so we have 17 lines of code. But look at this statement written in red color. You can see that it is starting by slash and then a star, and then it is ending by a star and a slash. Now this is a comment block. What is a comment? So whenever a programmer or anyone who's writing a program or a part of code is writing any, creating any code, they want to give instruction about what this program is going to do, right? For example, they might want to write who has created this code, when was the last date when this code was modified or when this was completed, and what is the various utility of this code, right? So you can have all these details here. A comment is only for the purpose of giving information. So you can say that it is a type of a documentation. It does not form a part of your compiled code. It is going to be ignored by your compiler. Compiler is not going to change these statements into some machine level code. No, it is going to ignore these statements. This is just being created to provide description about what this program is doing, who created it, when was it created, when was it last modified, what are the various components that this program is going to have. So all those details can be written here. Now this slash and star and then closing it with a star and slash, this is a multiple line comment or a comment block. So anything that goes in between them is not going to be a part of your compiled code. It is going to be ignored by your compiler. Next, we have this hash include. We have included a standard input output library header file. We have this main method, and in this you see local declaration is again in red color. But this is not starting with a slash and a star. This is double slash. This is a single line comment. The first one was multiple line comments. This is a single line comment. Okay, so you have two types of comments. If you want to write multiple statements all together, you can use a multiple line comment or a comment block. If you want to write small instruction as a comment or maybe small few words, then you can use this single line comment. Okay. So slash star, this is a comment. This is a block comment that covers 2 lines. And then we have another example, slash star, and in between we have written about 5 lines. It is a very common style to put the opening token on a line by itself, followed by the documentation, and then the closing token on a separate line. Some programmers also like to put asterisks at the beginning of each line to clearly mark the comment. So this is just a way of writing. Even if you don't put these stars, it is still okay. You just need to open with a slash and a star and close with a star and a slash, reverse order. That is a multiple line comment. Then we have double slash, which is a single line comment. So that is it for today. What all we discussed today was what is C? It is a programming language. It is a middle level language. It is structured in nature, means that it can be broken into subparts. It is easy to understand, easy to code in, and then it is easy to extend it and add functionalities to our already existing code. We saw lots of features related to C. We saw the history of C, when was it created, who created it, and so on. And then we also saw some usages of C language. For following that, we discuss a basic structure of a C program and a basic greeting program which printed a hello world message onto your output or console. Then we winded up with our lecture with comments, which is an important part of any program, though it is not logic, but it is still going to provide you an information about what that program is going to do. And hence it is very important. So this is comments. I hope you all enjoyed the lecture. If you have any doubts regarding today's session, you can mail me your doubts at varshasasodia@galgotiasuniversity.edu.in. Thank you so much. I hope you all enjoyed.